Hello everyone and welcome to section 9.6. We are going to be solving rational expressions. Okay, so this is just like what we learned last week, except with a little extra bonus. So we would have something like last week where we'd have 2 over x plus 3 plus, let's say, 3 halves. And we would just have to simplify it from here. Well, now we're going to learn when this actually equals something. Let's say this equals 19 over 10. Okay? Now, this works just like before. The first thing we're going to do is we're going to find the LCD. So, if we look at our denominators, we've got x plus 3, 2, and 10. Okay? So, if we look at this, we've got x plus 3, and then we've got 2, and then we've got 10. Okay, so here we've got some variables, we've got a couple numbers here. Okay, here's how this works. Write down, or you can factor this. This is 2 times 1, and this is 5 times 2, or you can just think, what do 2 and 10 both go into? Well, our winner is going to be 10. Okay, so we write down our LCD is actually going to be 10 times x plus 3. Okay? So, what we would do is we would change, last week we would change each denominator to 10 times x plus 3. This week, however, we're going to do it a little bit differently. We're going to take our LCD and we're going to multiply it by every term in here. So, to kind of cancel our denominators. Okay? So, let's look at this again. Let's rewrite it. But instead, we're going to multiply over here by 10 times x plus 3 over 1. And right here, we're also going to multiply by 10 times x plus 3 over 1. And here as well, times 10, x plus 3, getting a little crowded, over 1. Okay? So if we look, right here, the x plus 3's are going to cancel, leaving us with just 10 times 2, or 20. Okay? Now, over here, there's no x plus 3 to cancel, but the 2 will cancel. 2 goes into 10 5 times. Okay? So, just like before, we put a little 5 right here. Well, 5 times 3 gives me 15. So that term actually simplifies down. We have plus 15 times x plus 3 equals, and over here the 10's cancel, leaving us 19 times x plus 3. Okay? Now, this is just a normal equation that we can solve for. We can distribute the 15 and distribute the 19 and solve from there, or, little trick, this is 15 x plus 3's and we've got 19 x plus 3's. So what if I subtract 15 over here, and I subtract 15 over here? Well, 20 remains unchanged, so I've got 20 equals. Now I've got 19 x plus 3's minus 15 x plus 3's. Well, that leaves me 4 x plus 3's. Okay? Now I can divide by 4. So I've got 5 equals x plus 3. Subtract 3, 3, and I've got 2 equals x. And that would be my final answer. Now, the beautiful thing about this is you could plug 2 back into our equation everywhere there's an x, and you could check and make sure that you get the right answer. It's a beautiful thing. Now, let's do a more complex problem. Let's say instead of just fairly simple denominators, let's say we've got 7x over 3x plus 3 minus, let's say, 5 over 4x minus 4, and then equals 3x over 2x plus 2. Okay? Now, again, first thing we need to do is find the LCD. Okay, so we're going to look at each of our denominators. Now, if you look at these, you can simplify these further than they are. This one would become 3 times x plus 1. This one would be 4 times x minus 1. This would be 2 times x plus 1. Okay, so our LCD, again, you start with the numbers. What do 3, 4, and 2 all three go into? Well, they all go into 12. That's their least common multiple. Then you write down your other terms every time they appear, the maximum number of times they appear for each term. So if you look, kind of separate these, x plus 1 appears once, so we write it down once. X minus 1 appears once, so we write it down once. Right here is our LCD. So just like before, we're going to need to rewrite our problem. So let's go 7x, and let's rewrite it in its factored form. And minus, we'll go 4 times x minus 1. And I'm going to leave some space because I'm going to have to multiply 3x over 2 times x plus 1. Okay, now let's multiply by our LCD, multiply straight through so we can cancel our denominators. So let's multiply this by 12 times x plus 1 times x minus 1 over 1. And let's multiply this as well by 12 x plus 1 x minus 1 over 1, and also over here. What we do to one side we have to do to the other, all over 1. Now let's look and see what can cancel. Over here our x plus 1's will cancel, and our 3 will also cancel. 3 goes into 12 4 times. Well, 4 times 7x gives me 28x times x minus 1. And over here, our x minus 1's cancel, and 4 goes into 12 3 times. Well, 5 times 3 gives me 15. So minus 15 times x plus 1. And over here, our x plus 1's cancel, and 2 goes into 12 6 times. So 6 times 3x is 18x, and then also times x minus 1. Now, again, same kind of trick. We've got 18x times x minus 1, and we've got 28x times x minus 1. We can subtract 18x times x minus 1 and get it over here. Okay, so 28 times minus 18 gives me 10x times x minus 1 minus 15 times x plus 1. And over here, this simplifies down to 0. Well, this, we're going to distribute this. Distribute both. So we've got 10x squared minus 10x, and then we've got minus 15x minus 15 equals 0. Well, if we combine like terms, that gives us 10x squared minus 25x minus 15 equals 0. This is just a quadratic equation that we can factor. But let's make our lives a little bit easier and divide both sides by 5. That gives me 2x squared minus 5x minus 3 equals 0. Well, the only way to break up 2x squared is to go 2x and x equals 0. Now we need factors of negative 3 that we can get to add up to negative 5 using 2. Well, if we go minus 3 and plus 1, we FOIL that, that gives us right where we need. So if you set each parenthesis equal to 0, you would end up with x equals negative 1/2 and positive 3. And that, my friends, is solving rational expressions.